Okay, today we're just going to discuss MVVM as a design pattern, right? Now, this is not totally new to you. You've done some work with MVVM already. But I had a discussion with students in class the other day, and the universal feeling was that it'd be worthwhile reviewing it at this point. And I feel strongly about that as well because as a design pattern, it harmonizes so well with what we've just been doing, our work on unit testing, right? Now, the other thing is, of course, people are sick to death of MVC, right? However, MVC is a great and powerful pattern. And you know what, especially doing an application as a progressive web app with some, although limited, but some offline capability as well, it's amazing what you can do with MVC. That being said, going forward, with a dedicated client application, perhaps using a web API or other data repository in the background, so to speak, there's a lot to be said for MVVM, especially as I pointed out how it harmonizes with unit testing. So bear with us there. We're going to do a review of MVVM and talk about why it is so important going forward and review maybe a slightly different angle from what you've done already, your work with MVVM. So hopefully you'll find, I'm quite certain you're going to find this a very worthwhile endeavor. Okay, well, let's get into it. All good stories start with once upon a time, right? Well, that's where I'm going to begin today. I've been around for, maybe a couple years, right? So I remember the earlier days where, writing an application, you'd go and you'd get data from the database in some form or another, and you'd write all these assignment statements. First name equals this, last name goes over here, and so on and so forth. So you'd write all this code to basically copy the data you just got from the database into elements of a form or that are going to appear on the screen, whatever, right? One at a time. And then to save a record, okay, you'd go and you go through, again, pull out the first name, pull out the employee's department, pull out, all this information one line at a time, and you write all that code to get the data out of the form and into maybe a variable or use something like SQL, build it up dynamically, all different approaches there to save the data into the database, right? Very, very manual process was involved. Then along came property binding. Now that's, of course, harmonized with object-oriented design in general, right? Objects and objects having properties, right? So by binding or associating a given element in the user interface to a property of an object, it greatly reduced the amount of code that we needed to write, right? Taking away all those assignment statements. Even if you think about it with our MVC applications, where we have the data coming in a HTTP post, right, to an action, and it's all there in the post, and then we use something like bind, right, to actually take all the data coming in and bind it to specific properties of an object and build the object right there as the data comes in. In the old days, that was a huge amount of code to write manually, and we just did it basically in one line of code, even in MVC, right? So the idea of binding has been around now for quite a few years, okay? So what we do is we associate that or bind the property, and it just copies back and forth for us. Really cuts down on the amount of work we have to do and the amount of code we have to write, and of course, the opportunity for us to make errors and boo-boos in all the code that we manually put together, right? So directly binding an object to a form, and then the binding context with that in place allows us then to easily assign properties of the object to the different elements of the form, right? So the object is bound to the form, the properties to the elements in the form. And it makes life so much easier, and we're going to be doing that. We've already done it, right? But we're going to be doing it with an even more refined approach. But still, even with binding, the focus often has been on basically a two-step operation. You get the data from the database or whatever, and you push it out to the screen, right? You get it up there in front of the user. They work away, make changes, modifications, do whatever it is they need and want to do. And then when they're finished, okay, you pull it all back down and save it, right? Kind of a two-step process. But that's really a simplification of how apps today need to work, right? So that's something else we're going to address as we go through and learn about this design pattern. Is, there's often interactions that happen outside of just the two-step push and pull approach. Okay. So, it was all great up to that point, but there was still a lot of code we had to write to handle all the different events, like the clicking of buttons, like save, cancel buttons, refresh buttons, whatever, right? And then the other thing we just kind of hinted at about this push-pull business, there are other interactions that we want to respond to besides just, okay, get the data up, now pull it back down, right? They might interact with the UI, changing options that will affect what data is displayed on the screen, for example, right? It would prompt immediate changes to the UI. For example, even filtering, okay? They apply a filter and suddenly we have to go get a fresh set of data with a filter applied. Or we might even have cascading drop-down lists where, one option then filters what options are available in the next and the next and the next and so on, right? So really, we get away from just having that two-step mentality, and we need to be able to respond and notify all the different aspects of the application about things that are happening, right? Notify immediately about changes that happen either in the data or in the configuration of controls in the UI, back and forth and in between. Okay, now a lot of that code up to now has been put into our code behind page, and it works, right? So what's wrong with that? Hey, it works. And how many times have I said it? Get it working first, and then come back, revisit, look at enhancements, look at improvements in efficiency and so on, but get it working first, right? So code behind does the job, and we've used it, you've used it with in other classes, with other faculty and so on. And, for the most part, it's a good thing to learn and have in your toolkit first. But we're going to try to go a bit beyond that and see what this new MVVM pattern can give to us, make our development more efficient and more sustainable in terms of being able to make changes very quickly without breaking things, right? Okay. So as I say here, there's a couple things that really kind of impel us to move forward and get beyond just the code behind paradigm. Right? As I say here, some developers kind of thought, well, you know what? It's great how much code we've saved, how much less work there is using binding of properties, right? To get the data back and forth out of a form into objects and so on and so forth. Why? Why can't we also bind events as well? Well, we can, and that's what we're going to do, right? And right now, all the event handling code is in the code behind because that's where it pretty much needed to be up till now. But now we're going to actually get it out of the code behind and into something else. Okay? The other big thing that has prompted us to think differently about the situation is unit testing. Now, we've been learning about unit testing, and we focused on little classes that perform calculations and do logic of different sorts and so on, right? But truth is, we eventually are going to learn how to do unit testing of forms and user interface and, of course, models and so on and so forth as well. And, create a repository, do unit testing of the repository to make sure it's doing what it needs to do and so on. So it goes much beyond what we've already introduced now. Trouble with unit testing is to test an object, it's got to be up and going, right? And as soon as you have to run an application every time you run a little unit test on it, well, that becomes a huge amount of overhead. We'll talk more about that in a few minutes, but unit testing is something else that is prompting us to move away from just using code behind. Okay, actually, I guess it comes up right now, right? So anytime we want to run a unit test designed to test a page, a form, anything that's part of the UI for sure, well, you actually have to instantiate those objects. You got to load them up in the environment where they can run and live and be happy and so on, right? So that immediately puts a tremendous load. Okay, there's an overhead on running a playlist of tests and making it slow and expensive in terms of system resources as well, right? So all of these issues we can address with our new MVVM. I say new, it's actually been around for quite a few years now, but with the model view model pattern, right? Because what this gives us is loose coupling, right? A separation of concerns is another way to put that, between the UI controls and the business logic, right? What we're going to do is we're going to get pretty much all of the business logic out of that code behind page and into a separate class. Then we can just focus on that class, and we can do our unit tests, for the most part, all based on the functionality offered by that class to make sure it's doing what it needs to do. And that class, because it's not part of the UI, we can test without having to spin up the whole application, right? So that clean separation between the business and presentation logic, okay, and the user interface, that will really make unit testing in particular much, much easier. But you know what? It's not just about unit testing. This really opens up the door to a lot of code reuse where we can centralize things into one, little utility somewhere, things like that, right? A lot of code reuse. And of course, it all as well with that separation of concerns, different developers to work on the user interface independently of those that are working on the business logic, so to speak, right? With that separation, it allows team development to go forward, with much less problems developing in interaction between the two areas. Now, this also moves, as I said, the code out of the code behind and into what we're going to call the view model, right? Now, it's kind of unfortunate in some ways that we've been using the term view model, right? We introduced it a while back. It's not a wrong use, what we've done in the past. It's just we're expanding. We're going to expand the capabilities of our view models. Basically, we've reached out to use a view model in the past when we wanted to prepare or present information in a specific way to the user interface that didn't quite line up, didn't quite match exactly with how the entity models that relate to the database actually work with the data, right? So we used the view model instead. So we're going to take that concept and we'll still run with it, but we're going to add more power and capability to the view model, and that will allow us as well to be able to move that logic, that code from the code behind into this class at the same time. So it'll be the main companion to work along with the actual view, right? Which, for example, with a UWP or a MAUI page is often a content page of some sort, written likely with XAML and so on, right? Okay. All right, so those are some of the reasons why we're going to take time to learn a little bit about model view, view model, right? Now, this is a diagram right out of one of the tutorials. I stole it. Okay, I confess, I didn't draw this myself. You can probably tell, right? But it kind of illustrates nicely with these different lines, how these different objects relate to each other. So remember, the view is essentially what you see on the screen, the user interface, right? So as I note here, the solid lines in this diagram indicate that the view knows about, or if you want to say, works with the view model, right? And that communication happens largely through data binding and commands. With commands, we can actually, it's like a data binding, okay? We can bind a command of a user interface element to what we expose as a I command using the I command interface inside the view model itself, right? So that's how we get around quick events and things like that, as we associate these commands. So that works between the view and the view model. Then we have another solid line, right, between the view model and the model, right? So the view model knows about and works with the actual model as well, right? So it understands the data and so on, and it will update the model. And typically, though, that solid line there with the arrow pointing between view model and model, right? We accomplish much of that often using things like we've done in the past, like a repository design pattern, for example, right? So that's the solid lines, and that's how it works. So the view knows about the view model knows about the model, but the dotted lines, okay, they indicate that the fact is the model has no knowledge of, doesn't have any concern or care or any dependency on the view model, right? It can send notifications, okay, and that's fine, but it doesn't really care much about the view model in terms of what it has to get done. And in a similar way, the view model doesn't depend on the view, okay? It knows very little about the view, in fact, nothing, right? It can send notifications, I should say, just as the dotted line indicates, but it is not dependent on the view in any way. So setting it up in this manner, right, between these three different components, so to speak, gives us tremendous flexibility, right? The end result, as I say here, is that the view model isolates the view, right, the user interface from the data domain, the model itself. And that is an ideal arrangement for development, right? Ideal. Why is it ideal? Well, here's some of the advantages of MVVM, okay? Well, we can move any existing business logic out of the model into the view model, okay? And that way we have our nice, simple, now we've been pretty much doing that. We haven't put much business logic into, with the exception of a bit of validation, right, into our POCO objects and so on and so forth, okay? But you might inherit an application where they have done a lot of coding inside the business layer, right, that you need to separate out. And we can get that into our view model instead of having it anywhere near the model classes. Also, as we've already touched on, creating unit tests, okay, for the model and the view model, and we can test the bejesus out of the model and the view model. Sorry, I shouldn't have said that word. Sorry, no, didn't mean to offend anybody. But we can test the model and the view model without even using the view, right? So we don't need to power up that UI and run all those engines to get them up and going just so we can do unit tests on the rest. Yeah, we might actually do some unit tests eventually on the UI itself, right? But those ones clearly will be separate, and it'll involve a test runner that spins up the UI first. That'll be the exception, though. Most of our testing won't involve the UI. Another big advantage, right? Because the UI can be modified without affecting the view model or model code, right? We could have a whole team of people working on just making the best user interface you could possibly design. And, you know, they could even do parallel development, make 3 or 4 different versions, right? Completely separate new versions and so on, and just plug it in, right? Just plug it in the application and everything should work just fine as long as they've added the proper bindings for both properties and commands, right? Then away you go. Nothing else to it. So they can work completely independently and not hold up or be an inconvenience to all the developers. The developers, that whole team is working on the models and the view models. And of course, then now they're not holding up and interfering with the work of the designers, right? So it's an ideal situation, especially in team development, having that complete separation of concerns in that way. Another big advantage of MVVM, okay? So I'm kind of repeating that point here. I think I elaborated a bit too much, but designers working in the view can do so independently while developers are working on the view model and the model components, right? So a lot of reasons to think about doing this, okay? Now, something else, we've talked about this theory, these 3 different components, view, model, and view model, right? But what code ends up going where? We've already indicated that much, not all, but much of the code from the code behind will migrate over into the view model. And if there was any business logic in the actual model classes, that too can migrate out of there and find a new happy home right in the view model itself, right? So let's take them one at a time. I'm going to start with the view, okay? So what code goes where? What goes into the view? Well, as we know, this is our UI. That defines the structure, layout, appearance, etc. of what we see on the screen, right? Now, how you create this, okay, I'm going to pretty much follow the assumption that we're doing either UWP or probably even more likely MAUI at this point in time, right? So it's probably written with XAML because you could do it all in code, but it's so much more efficient to write some XAML, right? 1 line of XAML can be 50 lines of C# code. So yeah, it's probably going to be written in XAML, right? And it allows us to have a very limited, sometimes only a couple lines of code in the code behind itself, okay? None of the business logic goes in the code behind at all, right? Usually all we ended up is putting there is plumbing needed to, say, instantiate the binding context, right? That, hey, this view model object over there, we're going to bind that to the view. And that's all the code we often put in the code behind using MVVM, right? Okay, now there could be some little bit of extra code we throw in there for things that are strictly about the view. As it says, visual behaviors, things like animations and so on. They might require a little bit of code in the code behind, but nothing in relation to the data domain whatsoever would go in the code behind of our view in this new approach, right? Now, this view, it might be, as we've seen already, a content view, a content page. Okay, those will both have a small amount of code in the code behind, usually, as I said, to just define the relationship between a particular view model and bind it to the data context of the actual view, right? There's also a data template. So you can actually have a data template be the view, and there's no code behind for it. Now, to trigger code execution in the view model, right, when a user interacts with the view, clicking a button, choosing an option, whatever, there's a few different ways you can do it, but basically this first one here is the one you're going to use 99% of the time. What we do is we build a method inside the view model, and it implements the I command property, right? And then we can go to the UI and the elements written in XAML, and many of them, you'll find the vast majority, have a property called command. So that is how the binding for commands works. I mean, we already know how it works for data, right? We've been doing that for a while. We can bind, a data-bound property of the view model, in this case, to a data property of an element in the view, right? We've done that before. But for commands, this is new for us. So it's I command in the view model to a command property of an element in the view, right? When the controls command is invoked in the UI, the code in the view model will be executed. Simple as that. So we bypass the code behind, we go directly binding it to these methods made public by the view model itself. Now, sometimes some view elements won't have a command property. As I said, the vast majority of them do. In that case, you can create a separate object. You can define a behavior and attach it to the element in the view, and that behavior can listen for an event and then invoke the I command in the view model. So that often involves a little wee bit of code then added to the code behind, but it's really just to facilitate those small number of controls that don't have a built-in command property. So that's, kind of summarizing much of what goes inside the view itself, right? Lots of XAML. Make it pretty, make it beautiful, make it functional, right? And then just bind the data and the commands to your view model. Okay. Now, talking about the view model itself then, what code goes in here, right? Well, obviously we just talked about it has properties and it has commands that the view can bind to. So that's where much of the code is going to come from, right? So it can directly interact with the view, okay, responding to commands, exposing properties to be bound, etc., right? It notifies the view of any state changes. So, perhaps a notification comes through about a change in somewhere else in the application. Well, then actually it can make effort to update the view that's up on the screen right away with changes that are propagating through the system, right? So as I say here in short, the properties and commands provided by the view model really define the functionality that is available or offered to the UI, right? But it's actually the view, it's the view's responsibility to figure out how that functionality is going to be displayed to the user. So again, tremendous separation of concerns between the two. Now, I've got a note there in italics, something very important. We want the UI to be responsive. So basically, forget about anything that's synchronous. We should always be using asynchronous operations in between all the different layers that we're talking about here. Okay, do everything that you can asynchronously. It will keep your application more responsive. Okay. Now, getting back to the code in the view model itself, now it typically works with at least one, but often multiple models, right? Sort of think of the database models, our POCOs and so on. It also coordinates the view's interaction with any model classes, right? So it, deals with the whole data domain. Any data conversions that are required, and sometimes that's necessary. We've created converters in the past, okay, just to go between incompatible data types that need to be converted back and forth. Well, that could be part of the the view model, bite my tongue, the view model, or we might create a separate conversion layer as well as part of the application to handle conversions, right? Okay. Now, finally, we get to the actual model itself, right? So we've used models in the past. This one changes the least in this new design pattern from what we've been doing in the past, right? It's quite often, as I say here, plain old CLR objects or POCOs. We might have data transfer objects. That's also part of the model, okay? Basically, as I say, it represents the application's domain model, okay? That includes the data model along with any business and validation logic, right? That's all part of the model. And it's typically used along with services, a service layer, or repositories. Now, the repository, that's the approach we've done together most often. Creating a repository is an abstraction, so it just exposes simple methods, right? To add, update, delete, right? And then how that happens in the background, we don't have to care. We just have a repository that does it. A service layer is very similar in concept to a repository, and sometimes you combine them both, okay? We haven't gotten that far in terms of building examples using the service architecture, but it's really just kind of a twist on the idea of a repository, just a little bit more broad in its scope. In any case, right, along with the POCOs and everything else, we'll use probably some kind of repository or service layer to encapsulate data, get the access in place and the caching if that's involved, and so on and so forth, right? Okay, so where are we going from here? Well, all right, we're just having this discussion today, but in class this week, we'll start exploring actually putting this into play. We're going to take some simple examples and just put the MVVM pattern into play. Now, we'll do it manually at first, right? The tutorials talk about two different approaches to how you can get that marriage in place between the view and the view model, right? You can do view first composition, okay, or view model first composition. Basically, it's a small difference, but in view first, you basically, in the XAML, you define that, hey, here is my buddy, okay? Me as a page or a view, my friend, my view model is this one, and that's all defined right in the XAML of the page. More often than not, I tend to go with the view model first composition approach, which basically in the constructor, okay, that little bit of code we often end up adding in the constructor of the code behind page for the view itself is where we associate it with a given view model, right? And that's view model first composition, okay? And that allows, sorry, the dogs are barking. There's workers working outside here. So anyway, I lost my thought. Yeah, so that's how we can, two different ways to connect the view model and the view itself, right? Okay, we'll also use declarative construction and programmatic construction to create the view model and bind it to the view. And we'll look at implementing iNotify property change. So this is really the key to much of what goes on, right? We need to have our objects capable of sending notifications. So if something comes along and changes a property, well, we talked already about the idea that the view model would let the model know, or the view know that this property has changed. So it might be necessary to do something different in the user interface, for example, right? A note here that all, whether it's an actual model, because sometimes we will bind a model object directly to a view, right? As long as the view model's in charge, okay? So we can bind a model or a view model. Whatever classes are accessible to the view must, okay? Instead of should, I should say must implement iNotify property change, that interface, right? And that raises an event anytime any property is changed. We'll look at that in more detail in the coming week, right? So we're going to look at doing that manually, getting that code in place so we can see very quickly how easily it makes managing the whole flow of information back and forth through the view to the data domain and back again with iNotify property changed. It can look after a lot of events for us that we otherwise would have to intervene with ourselves. Okay, it goes along very well with binding, right? The concept of binding both properties and commands themselves. So the other thing we're going to introduce, hopefully before the end of this week, or maybe this might hold off till next week, is the community toolkit. Okay, if you go, you'll find a NuGet package called this specific name, Community Toolkit MVVM. And what it does is it tremendously simplifies. Okay, it's kind of like I plan on being really mean and showing you the long, difficult way of implementing iNotify property change, writing all this code here and there to raise the property changed events and so on. And then I'm going to say, ha, 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 now you've learned all the hard way to do it. Here's the easy way. So I might even skip pretty quickly to the easy way because we don't have a lot of time left in the term. Using the community toolkit, right, it really simplifies and speeds up our development, okay? We'll probably focus mostly on using Maui as our demonstration platform. But the idea is that using the toolkit, we can just simply, hey, add a data annotation basically to a class and another one to a property, and bang, it automatically writes all the code to implement iNotify property change for us. Now, how many people don't like a tool that's well tested and reliable and does your work? Not too many students I know of won't enjoy that. So it's something that pretty much all developers have adopted, this community toolkit. Of course, you're free to sign up and contribute to it. It's an open source project on GitHub, right? So you can feel free to add to it yourself as long as they'll let you, right? But the most important thing is it's going to really simplify implementing MVVM. And that brings me to the end of our discussion. Now, I've used a good portion of our time today, but what I did want to do now, let me stop my recording though.